is December 12th. It's going to be rather cold here in the Chicago Midwest area tomorrow. In fact, the high temperature tomorrow is going to be 12 degrees below zero. So it's definitely winter has set in here, but no problem. We'll just continue on here.
Yes.
So anyway, we finished up talking to different generations, and we're working our way through the generations, and we just introduced the third generation. Now the time frame here, remember, would be the very, very late 1990s, the early 2000s. And the thing about the third generation compared to the second generation is they were just about the same architecturally. There's a few changes. The biggest change on third generation was the air interface, the interface between the mobile and the radio tower was wideband CDMA. Those radio towers in second generation systems were called BTS, base transceiver stations. And now in 3G, they had the strange name of Node B, Node, no space, and a capital B. Why they named that Node B, I have no idea. But we ended up somewhere right around here. Let me get to the slide. I think this was it right about here. We were looking at third generation systems, and remember, a couple things happened with these third generation systems. The specifications now, instead of being written primarily by the European Telecom Standards Institute, are now over to a more of a group of organizations. That's these right here. So these first top 1, 2, 3, 4, 5, 6, 7. These first top ones right here. They formed a group called 3GPP, Third Generation Partnership Project. And this other group here, from this point on down to here, formed a separate group called 3GPP2 with the numeral 2. So and that's no longer there today. But the one with the 3GPP2 was the narrowband CDMA, what was going on in the Americas primarily, in North and South America and other countries. But Europe and most of the rest of the world were following the GSM standard. That's what came out of this 3GPP. So it kind of looked like this. You had this group here, which was the second generation was GSM. The third generation was now called UMTS, Universal Mobile Telecommunications System. And the radio interface was a wideband CDMA primarily. There was a couple that did not, but most of it was wideband CDMA. And then it was enhanced further. In other words, it got faster and faster with things like high-speed downlink packet access, high-speed uplink packet access. The other group that was following kind of the North America was CDMA as the second generation. It was called CDMA 2000 for 3G. And that used a narrowband CDMA. And there was another provider out there with something called WiMAX. So that was 3G. So that's kind of setting the stage for what's going on with third generation. So third generation systems looked like this. It looked very much like the 2.5G, like the general packet radio service. You had, well, first of all, your mobile phone now was called the user equipment instead of the mobile station. It was called the user equipment. Your subscriber identity module would have been inside there. The air interface was now a wideband CDMA. That was that big 5 megahertz chunk of frequency that you're assigned these unique codes. The cell towers are called Node Bs. Kind of a strange name, but it's called the Node B. That's the actual cell towers. And these would connect to a radio network controller. Remember, in 2G, those would be base transceiver stations, where the cell towers, and then base station controllers. So again, some new names here. What you had here on 3G was the radio network controller would make the determination on whether this was a circuit switched call or a packet switched call. If it was a circuit switch call, you were maybe texting a short message, or you were placing or receiving a voice call. That's a circuit switched service. The packet switch service, you're downloading data. You're using your mobile phone to access data. Now the data in here was not very fast. This was not megabits. This was in the kilobits. This was maybe downloading documents, no video or anything like that. But this radio network controller, you had an interface going back to the mobile switch for the circuit side, and you had a packet switch interface going to this serving GPRS support node, which was the same name as 2.5G, and the gateway GPRS support node accessing the packet network. This was now a user, a pipe, a user tunnel, and this was a user tunnel. So this used what's known as GTP, GPRS tunneling protocol. Again, think of it like a pipe. You're carrying information inside that pipe. It's like a VPN, a virtual private network, how they work today. So everything else was the same. You still had your mobile switch and your visitor location register. You still had trunking or voice path connections to the public switched telephone network, which would have been the wireline network. You had trunking to other mobile network operators, and your signaling, the way you communicated through these other devices, like the equipment identity register, the authentication center, the home location, the message center, all these devices that we talked about earlier are still there in 3G. And the communication path here, everything in red here was SS7, Signaling System 7. This in blue was GTP, not this part here, just right here and right here was GTP. So this was the overall architecture. So it really looked very, very much like 2.5G, except you had a wideband CDMA air interface, and you had this, and you had a GTP pipe right here that was new for 3G. So the primary signaling protocols were these. You had now two primary signaling protocols, just like you did in 2.5G. All the communication path on the mobile switch to all of its internal devices, SS7. One network would talk to another network for purposes of roaming over SS7. Remember, this is the device, this STP, signaling transfer point. This is the router. This is the device that routes SS7 messages. And an STP, a signaling transfer point in this network, would connect to another signaling transfer point in another network. This is, for example, the home public land mobile network and the visited public land mobile network. So if this subscriber was in their home network, they would access the packet network and then other networks here. But if they were roaming, this network would need to communicate back to the home network for purposes of roaming and getting information about that subscriber. And like we showed yesterday or 2 days ago, GTP, if you're in your home network, your data, if you're using for data now, your data would go this path, would go through that GTP tunnel, that pipe, and it'll go through a GTP tunnel to this gateway device out to the packet network. If you're roaming, you could do that. But what is done in actuality is that tunnel is set up to your gateway GPRS support node, so you access your packet data in the home network. So if you use your mobile phone and you're roaming, www.anything.com, and you're roaming in another network, that data gets sent back to the home system, and they measure your data. Now, if you use your phone to place a call, then you use the visited system. You use the circuit switch part of the visited system. So it's kind of an important distinction. So this was 3G. So 3G came out, there's different releases. The 3GPP, Third Generation Partnership Project, they have different releases. They release updated documents roughly every 18 months, maybe 19 months. It's not every year, but they will release new versions of their documents. So when 3G came out, it was what was known as Release 99. Before that was Release 98, then Release 99. The next release after 99 was Release 4. Why? Don't know. But then 5, 6, 7, 8, and so on. Currently, the most current release right now is 18 or 19. So again, it doesn't quite follow the years. So 3G came out in Release 99. There was a little upgrade in Release 4. which came out like 2002, 2003, and then came release 5. And in release 5, there was an additional optional architecture that was introduced. This is the additional architecture, was this right here. So just to kind of look at everything, you had your mobile phone, you had your air interface out here, you had your radio towers, which were called Node Bs. They would connect up to a radio network controller. You would communicate with your mobile switch for circuit services, for voice calls, for short message service, for call forwarding, call waiting, those type of circuit services. If you're using your mobile for a packet network, though, or packet data, this would set up a GTP tunnel to the serving gateway, and it set up a GTP tunnel to the gateway GPRS support node, a GTP tunnel. But now they introduced this optional architecture. So you had a circuit switched network here, you had a packet switched network here, and now you had an optional network which was called the IMS, the IP Multimedia Subsystem. And the idea here was to bring multimedia services from this brand new thing called the internet and these other packet data, which were relatively new in 2002, 2003. So we're going to bring these services, these internet type services, into the mobile network. So they introduced this optional architecture. And inside this optional architecture, there's a couple different protocols that are used inside of here. One is this one, and one is this one. This one is called SIP, Session Initiation Protocol. This one is called Diameter. So there's two new protocols. So now with 3G, we've got kind of a lot of different signaling protocols. You've got SS7, which is managing the mobile. It's doing your update location, it's doing your authentication, it's keeping track of the mobile, it's doing everything to know who you are. That's SS7. For data, it sets up these pipes, these data tunnels, and inside those tunnels, you carry data packets. So when you do www.anything.com, that is sent through up the air interface. It gets sent to this radio network controller. It gets placed inside of that tunnel. That tunnel is set up between here to here. And inside that tunnel is a data packet, the data packet www.anything.com. And the same thing with right here. And that's how the data gets into the packet network, through these data tunnels. But now we have an optional architecture called the IP Multimedia Subsystem, which has SIP servers, which are called Call Session Control Functions. Those are SIP servers. You have application servers. You have media servers, so you can hear voice announcements. You have various gateways, which basically what a gateway does is converts one protocol to another. So you might have SIP to SS7. We'll talk more about that later, but there's different protocol that gets converted. Well, this optional architecture was very complicated. And as it turns out, there were not a lot of services that companies were interested in. You might do things like push to talk over cellular. You might do things like presence services or instant messaging, things like that, which the network was handling just fine. So they really didn't need this architecture. So this was an optional architecture, an optional network that most companies, if they installed it, they didn't do too much with it. Now, that's not true today. Today, and we'll talk about that in a little bit, but today this is very, very much used. But back in 2002, 2003, very, very little was used in this. But again, it became known in release 5. So you had your 3G was release 99, then came release 4, then came release 5, and then 6, 7, and so on. So these are just the releases that came out at that period of time in the early 2000s. So I just wanted to kind of highlight these different releases. We're right around here. Some of these are 19 today. Not all the specifications are on 19. So we're right around here today. Now, the major things, and as these releases come out roughly every year and a half, they add functionality. Now, just because a new release comes out, this isn't like you going out and buying a new TV set or a car where, you buy a new TV, you throw the old one away and you put in a new one. These things, just because they come out with new releases, doesn't mean that every network out there always has the best release or the latest release. They might install some of the features, maybe none of the features. And architectures change. The architecture changed a little bit with 3G and release 99. Then came release 4. Release 5 had this optional architecture that not too many used. Then came release 6, which was faster high-speed uplink packet access, faster high-speed packet access. Release 8 changed the architecture completely. That was now called LTE. And LTE stayed on, this was 4G. 4G technically came right about here on release 10. That was the 4th generation. Then release 11, release 12. You had a lot more going on. Now the architecture changed again about 3 or 4 years, about 6 or 7 years ago. 5G was introduced in release 15. So again, not every network, not every mobile network will just, we have a new release, let's throw everything away. I mean, they sometimes they keep the 2G, 3G, and they add 4G. Sometimes they get rid of 2G, 3G, and put in 4G. Sometimes some of them are going into 5G, but they're not standalone 5G. Some of them are using the 5G radio, but the 4G network. So there's a real mix and match of these things out there. And I don't want to I know you're looking at this page and thinking all these acronyms, what all these things mean. Don't worry about the acronyms. Don't worry about that right now. But just keep in mind that 3GPP, third generation partnership project, they're the ones that define and write the standards. And the standards change, some of the architecture changes, some of the speeds change, and there's improvements roughly every 18 to 20 months, somewhere around there.
Yeah. Hello, Steve.
So now the time frame is getting to be 2007, 2008.
Hello,
Time
Steve.
is marching on. Yeah, please.
Yes. If we can go back to the last slides.
Sure.
Okay, so I was interested in knowing how the LTE worked, and then the push to talk over, how they worked.
Mm-hmm.
Yes.
Yeah, this was push to talk over LTE. This was a feature where you could use your mobile phone kind of like a walkie-talkie.
Okay.
So it would be used, just let's say you own a company, a trucking company or a taxi company, and you want to talk to your employees. Well, rather than call them on the phone, you set up almost like a private network, and you say, "Hey, Ralph, are you around there today? Over." And you just kind of you do it like a walkie-talkie. So that's what's known as push to talk.
Okay.
That's what that feature is. Now, whether anyone uses that feature or not, I'm not sure. LTE-M, this has to do with using the LTE network for IoT devices. Remember, the mobile networks today are a lot more than just your phone and talking and data. They're used in what's known as IoT, the Internet of Things. These are these little sensors, millions of these sensors that are measuring things. They're measuring traffic patterns. They're measuring water pressures. They're measuring all sorts of things, and they're using the cellular network for these remote little sensors that can now use the cellular network to communicate little bits of data. So the mobile networks are more than just you having a subscriber having a phone and talking to someone. They're used for the IoT, the Internet of Things. So that's what LTE-M is.
All right. Yeah, thanks for that.
Okay. So let's see what's happening now. What's happening in the late 2000s? Now this slide is dated to 2023, but around here, what is happening here? If you look at the red line, the data is, people are using their phone, data is just going crazy. Whereas the green line, the voice is pretty steady. So people still use their mobile phones for voice. It's not that voice goes away, but more and more and more and more data. So there's a tremendous growth in data. The other thing with 3G, you had a your radio towers, yeah, the same radio tower, but some of them were used for what's known as GPRS Edge Radio Access Network. One was for 3G. So, in other words, you could use your mobile phone as a 2G circuit switch device for voice, but you could also use it for data, which was a core network for circuit switched. You had a core network for packet switched. If I go back 2 slides, 3 slides, you have a circuit switched core network. That's for your circuit switch services, but this is for your packet switched services. So you're maintaining 2 different networks. And the radio network has to determine whether you're using the network for data or using it for circuit services like voice. The standards down here, number 3, the standards were getting very complex. You had 3G, you had uplink, high-speed packet access, you had downlink packet access, and the standards were getting very, very complex to maintain maintaining these 2 networks. Also, there's better modulation, and this was a key thing: the need for all IP. To get rid of circuit services completely and make the network completely IP, completely data centric, and spectral efficiency. But something else really happened. It was, I think, either June of either 2007 or 2008. Apple introduced the iPhone, and now the data was just growing. So there was a need for a better architecture. There was a need for a better air interface. There was a need for better efficiency on the air, and the network needed to be all IP. So in release 8, right here, they introduced a new architecture. That architecture was called LTE, and that's this. If you just look at just this top part here, just this top part here, 3G. With 3G, you had user equipment, you had your RAN, your radio access network. We had 2 of them. You had the base transceiver stations that were still there, the Node B, which was 3rd generation, and you communicated through that radio network controller. You had a circuit switched core network, which had your mobile switch, your visitor location register, your home location register, your authentication center, your equipment identity, your message center, all things for circuit-related services. But you also had a serving GPRS support node and a gateway GPRS support node to access the packet network. Quite complicated. So this core network became what's known as the Evolved Packet Core in 4G. This radio, this device, and this device, and this device now was into one device called the Enhanced Node B. So 3G called the cell tower the Node B. 4G calls it the Enhanced Node B. But all of this, the controller and everything is rolled up into one device on the radio tower. All the controllers are right here. Your user equipment is still called the user equipment. Remember, any network, any generation, 3 main parts to any network: your user equipment, your RAN, your radio access network, core network. On 3G, this was your user equipment. This here was your radio access network, and both of these were your core network, circuit switched and packet switched. All of these became this in 4G. Now, let's see what happened here in 4G. In 4G, your architecture was all IP, all IP. Your user equipment now is your phones, your smartphones, your laptops, your tablets, your IoT devices. These are all devices part of LTE. Your cell tower is now called the Enhanced Node B. It's the architecture of the radio is called Enhanced UTRAN, UMTS Terrestrial Radio Access Network. This is your radio. Instead of a controller, everything's built into that 4G. And your Your core network now is everything from here on, like I showed down here. This is your core network. The mobility management entity, MME, that took the place of these two things right here. Took the place of the mobile switch and the VLR. The visitor location register is now called the MME. The HLR, the home location register right here, is now called the HSS, the home subscriber server. The equipment identity register is still the equipment identity register. On the packet side, you had a serving GPRS support node and a gateway GPRS support node, and that is now called serving gateway and P gateway. You also have this other device. Now we'll talk briefly about this other device. This is called the policy and charging rules function. You can apply different policies to different data streams. You might be using your data to talk on the phone. You might be using it to surf the internet. You can have multiple data streams active at the same time, and you can apply different policies. A policy would be a latency, guaranteed bit rate, quality of service. You can apply different policies to different data streams through the P gateway, because remember, you got these different data pipes here going to these different networks. So that whole function was new in 4G. Now, so this was the architecture. It's a much flatter architecture. It's data only. It is data only. So you still have three parts: user equipment, RAN, and the core network. But there was another big change: the signaling. I'm going to go up 2 slides. I'm going to go up 3. I'm going to go right there. The signaling. Your signaling now is diameter. Instead of SS7 controlling the mobile, instead of SS7 doing the mobility management part for the mobile, there's a new protocol called diameter. And you still use GTP. So when this mobile talks, it is still, or this mobile does www.anything.com, that's still going to go through that GTP tunnel. It's going to go through a separate GTP tunnel and go out to the packet network. So it's a much flatter architecture. Now, one of the key things with 4G, it is data only. So my question to you is, what do you do for voice? How do you, if this is data only, how do you make a voice call on this network? Or how do you do short message service? Or how do you do call forwarding, call waiting? These are circuit related type of services. Anyone want to guess how you do those services?
Okay, I think there's one. Jeff, can you go on?
You use the SS7 protocols as a fallback for.
That's true. That's one of the ways you can do it. One of the ways you do it is right here. That's exactly right. One of the ways, I went up a couple slides. One of the ways is you make a connection back to your 2G, 3G. That's called circuit switched fallback. You fall back to the circuit switched world. When a call comes in for you, a message goes over here. This device commands the cell and it says, hey, tell that mobile to retune to a frequency up here. So this cell commands the mobile. It says, hey, retune to a frequency up here. That's how it places the call. On mobile originated call, it does the same thing. So that's true. You can do a circuit switch fallback. But there is one other way. This is a short term because eventually these networks, these mobile network operators are going to get rid of their 2G, 3G. The long term is get rid of 2G, 3G. Once you get rid of second and third generation mobiles, you got to handle voice and circuit services in a different way. the way you do that is this. You take that IP multimedia subsystem, that architecture that virtually no one used way back in release 5 and release 6, and that is what's now used now. And this device communicates through the 4G network into the IP multimedia subsystem, which gains access to other networks. That is the long term. It's called VoLTE, Voice over LTE. That's the long-term solution. And one more slide, it'll look like this. You use these data tunnels that are set up between the cell tower and the serving gateway, and another data tunnel between the serving gateway right here and the PDN gateway. And this mobile talks SIP, Session Initiation Protocol. So the SIP signaling goes over the air interface. The SIP message gets carried inside that tunnel. The SIP message gets carried inside that tunnel. The SIP message gets handed off to one of these SIP servers here, and that handles the call. So you're absolutely right. The two ways that you handle circuit services in an all IP network is either you fall back to the 2G, 3G, or the long term is you use your IP multimedia subsystem. Let me go back a few slides here. That was this part right here. So this is the architecture. It's data only. Voice, this device has to communicate up to a 2G, 3G network, or this device has to connect to the IP multimedia subsystem. And then this talks over the air session initiation protocol. It's carried through the tunnel here. It's carried through the tunnel here. It's handed off to the IP multimedia subsystem. And this is where we'll pick it up on next week. We didn't quite finish. We got a little more information to go for 4G and then 5G, and then we'll finish up. Yes.
Yeah.
Name? Question.
Can you hello? Can you rephrase it? I think. Can you find a better spot?
Yeah, the audio is I can't understand the audio. But if you could type it out
Using
here.
Yeah, the voice is clear now.
That's better.
using the voice over LTE, will you be able to still connect to the internet whilst on a phone call?
I'm sorry, using the voice over LTE, will I still be able to connect to what now?
The internet. Will you be able to connect to the internet whilst on a phone call?
That's an excellent point. In fact, I'm going to go to that slide right here. That's a very good point. Absolutely. Because you have multiple MMEs, you have multiple servers, and absolutely, you can talk on the phone, you can watch YouTube, you can have multiple data streams. Excellent point. Now, the policy function here will apply different rules to you on the internet than it will to you using a voice. It's going to give you a much higher quality of service. It's going to give you a lower latency. It's going to give you a better guaranteed bit rate for your voice than for the internet. The internet, it'll just do a kind of a best effort, because again, you're on the internet. But that's a very good point. Yes, you can. You can have multiple data streams open at the same time. The maximum used to be 11. I don't know if that's still the case. Good question. Well, all questions are good questions, but that was a good question.
Yes.
That was a timely question, okay?
Yeah.
Put it that way.
Yes.
That was very timely.
I think there's other question as well.
Yes, Jeff?
Go on.
Steve, in the circuit switched systems, when one person is moving from, like somebody's on a call and they're moving from one location to another location, you have them like protocols where they are switched from one um, cell to the other. So in using the LTE, like how does the like if you are moving from say one like 7 gateway to the other, like does it also do something similar where it transfers you to like maybe the next
Yes,
7 gateway?
I have a separate slide on that, not in this slide deck, but the question is, as you move around, how do you, let's say you're attached to a network here, how does that happen? Well, first of all, you'll maintain that same PDN gateway. This will stay attached here. You could get the different serving gateways. You move around to a different cell, that there's kind of different degrees of you being handed off. First of all, you'd be handed off from one cell to another cell, maintaining the same serving gateway. The next type of handoff is one cell to another cell, but then you change serving gateways. In that case, you'll set up a separate GTP tunnel, but you'll always maintain this PDN gateway as your anchor point, unless you move totally out of the network. If you move totally out of the network, then you would lose that connection. In other words, you would lose that IP connection if you lose totally out, because a PDN gateway in one network does not talk to a PDN gateway in another network. Okay?
Yes.
Good question. Good. Another good question. Another good timely question. That's excellent. Anything else?
But going back to the next question, sometimes I do like almost often I do experience in a way that when I'm using the internet on my phone and there is a call, like the access to the internet is blocked. Is there a reason why?
I'm sorry, I didn't. That you kind of faded out in that last part. What was the question?
Okay, so sometimes if I use the internet and there is a call, if I receive it, the internet gets cut off. Is there a reason?
Yeah, that's a possibility. I mean, it might do that, but again, that just might be the bandwidth of the network. But you certainly could stay on the phone. I mean, you know, if that's probably a network type of problem. Maybe there is not enough channels or something, or something's not configured quite right. Because normally I can be on the internet and I can get a call in there, and I maintain the connection. Yeah, you should be able to maintain a connection.
Okay.
And there's multiple P gateways. There's multiple PDN gateways. There's multiple serving. There's multiple MMEs, kind of like this. You can even have multiple HSSs. Logically, there's only one HSS. Physically, there's multiple. You can have many HSSs. But you can have multiple MMEs connected to different cell towers. You can have multiple serving gateways, multiple P gateways, and then of course other networks out here. So the network is going to vary. I don't want you to think it was just one P gateway in the network or one S gateway in the network. Okay?
Yeah.
Others. Okay, well, very good. I think we got one more session we're going to do next week, right?
That's on Monday, yes.
Oh, I don't hear you.
Okay.
You're muted.
Yeah, I think that's on Monday. So
okay, Monday the same time?
The same time. I'll send you the link.
Okay. Okay, that's good. Monday the same time, and I hopefully we'll finish this up. We'll finish 4G, and we're going to look at 5G also. That's kind of the latest and greatest. It's not coming on as fast as 4G. 4G came on real quick. Networks needed 4G because of data. 5G, it's kind of like, well, it's there, but 4G does pretty good job. So anyway, it's out there and it is coming, and companies are using it, but it's a different architecture altogether. We'll talk about that on Monday.
All right.
In the meantime, I'm going to go down here. I'm going to put all of you in front of me again so I can see you. Now you're in the front. Let me stop sharing. There we go. And we'll pick this up. We'll finish 4G and jump right into 5G on Monday.
Yes.
Okay.